problems by using dot plots. Let's get into it with our I will statements.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen to me first. I will create a dot plot. Read that one with me. I will create a dot plot. The second one, listen first. I will read a dot plot. Read that one with me. I will read a dot plot. And our last one, I will compare fractions on a dot plot. Read that one with me. I will compare fractions on a dot plot. Nice job, mathematicians. Let's get into it with our warm-up. So for this activity, I want you to write the mixed number 1 and 1/2 on your whiteboards. Now, we're going to draw a number bond to represent the whole and the fraction of this mixed number we have on our boards. If we were to look at 1 specifically, 1 written in halves would be 2 halves. It equals the same thing. We also then would have to bring down our 1/2 because we didn't use it yet. Now that we have this number bond here, we can take our two fractions on the bottom, 2 halves and 1/2, and let's add them together. When we add fractions, remember, if the denominator is the same, we leave it the same. And then we just add our numerators. 2 plus 1, everybody, is 3. So if we wanted to write our mixed number, 1 and 1/2, back as a fraction, it would equal 3 halves. We just basically did what we had to do in our first problem when we went from fractions to mixed numbers and reverse that for this activity. Let's do another one together. Erase your whiteboards. We'll do one more with me, and then I'll let you guys try one on your own. Let's do 1 2/3. Remember, always take the whole out first. So if we wanted to do that, we're going to change 1. We'll look at our denominator in the fraction to help us figure out how many parts or wholes we're going to break this whole number into. We're going to break it into 3 separate parts. And to get the whole number, we know we have all 3 parts. So we used our whole number. Let's bring down our fraction, 2/3, and add those together. The denominator is 3 over here. So in our answer, everybody, it would be 3. Nicely done. Write that on your whiteboards. And we have to add our numerators together. Write the numerator you think it is and hold up your whiteboards to see if it matches mine. Now we know that 1 2/3 as a fraction equals 5/3. Nice job, mathematicians. I'm going to give you guys one more to practice. While you guys practice this one, you are going to complete it by creating your number bond and turning it back into a fraction. After you do it and check it off with a partner, give yourself a minute to stretch and then come back as we get ready for our new material for today. All right, mathematicians, let's look at our problem set here. In the first problem, we're looking at a table that shows the distance that Miss Smith's 4th graders were able to run before they had to stop to take a break or take a rest. If we look at this table, we can see that it has students' names in the class, and we can also see that it has the distance, and some are labeled as mixed numbers, and some are just fractions. If we look at those mixed numbers and fractions, we can see that some of the fractions have different denominators, but all of the denominators are still fractions that can be made equivalent. I also can see that all of those fractions are representing miles. So we have to remember that later. If we're being asked to identify something, we want to remember that label. We're going to create a dot plot to show the information that is in this table here. Now, a dot plot is something that you might remember from 4th grade. It's kind of like a number line, but you don't put points on the line, you put marks above the line. And those different dots represent different amounts of, in this case, people. So it's almost like a bar graph because the different columns are showing us the most. We are going to look at the information in our table on our screens and on our papers to help us identify the endpoints for our number line and our dot plot. So if we look at when we need to look for that, that means we need to look for the largest fractions and the smallest fraction. So if we look on our list here, we can see that the smallest fraction is, point to the name on your paper who you think has the smallest fraction. Jenny has the smallest fraction at 5/8, and we can identify that because she also is the only one with a normal fraction, and it does not have a mixed number. If we wanted to find the largest fraction, we would have to compare all of our whole numbers. We can see that we have a lot of 2's here, and then we would have to think of which one has the biggest fraction. In this case, Jack has the biggest fraction at 2 and 5/8. If Jenny's at 5/8, I think we should make one of our endpoints 0, and if Jack is at the tallest at 2, or at the longest distance at 2 and 5/8, I think our other endpoint should be 3. Remember, we're going to use those whole numbers just as our endpoints. We might not plot anything on them, but they're going to give us starting points on our number line. Now it's time to create our number line. You're going to want to grab a ruler and then draw a straight line across, putting a 0 at one end and 3 at the other. Now that we have our number line on our boards or on our pieces of paper started, and we have the 0 and the 8, we need to mark off the distance between 0 and 3 to help us mark off the specific miles that the students ran. Let's put in the other whole numbers. So we have 0, let's add 1 and 2 in there. If we were to look at our chart and figure out what is the smallest of the units in the measurement chart, it's 1/8 of the mile. So we're going to need to split each of the sections up between each of these whole numbers into 8ths, which means you're going to need to draw 7 lines between each of these numbers. Pause the video and do that now so that your number line, now that we have our number line looking like this, if you need more time, pause the video and do that now. We have to add some other specifics to the number line so that we can represent some specifics that if someone were to look at this number line and they were to see the dot plot, they would be able to recognize it. So we have to add underneath what all of these little dashes represent. Each of these dashes is showing us the distance. So on your paper, write distance. And remember, in our table, it gave us the units. So we're going to write distance in miles. It's always good to have that unit. You don't want to forget it. Now that we have that label, we also want to add the title of our graph. So we know that this is looking at students in Miss 4th grade class, but specifically how much they ran. So let's add our title, distance Miss Smith's students. You got to go to the second line. It's okay if you don't have to. Ran. So now we have a title and we have a label for our dot plot. Now we need to add the actual information onto the graph using the information that we were given in the table. Looking at our table, the first student we were given information about was Joey. Joey ran 2.5 miles. Let's put that on our dot plot here. So we have to go to 2, and we have to go halfway between 2 and 3, which is going to be 1, 2, 3, 4 jumps over. Now with a dot plot, you're going to put a circle above your number line. That circle is going to represent one student. That one student for right now is Joey. Joey ran that 2.5 miles. We can even write that underneath for us to remember later. If we were to keep going, let's add Anna in. Anna ran 1 3/4 a mile. Now this is split into eighths. So if I had to think about fourths into eighths, 3/4 into eighths, that unknown number would give us 6/8. So we need to go to 1 6/8. 1, 2, 3, 4, 5, 6, and put our dot above that. Now we have 2 people. Let's continue. Bobby ran 2 1/8. Now, since our graph is already split up into eighths, we just go to 2 and count over 1. Remember, go above your line and put a dot. Let's keep going. Morgan ran 1 5/8. Again, this mixed number is already given to us in eighths. So we'll go over to 1. We'll just count up 5. 1, 2, 3, 4, 5. We'll put a dot above the 5th line. Make sure you're counting carefully. If you need more time to graph between any of our people, pause the video to take that time. Our next runner was Jack. Jack ran 2 5/8 of a mile. So we're going to go to 2 and count up 5. 1, 2, 3, 4, 5. And put a dot for Jack. Now we have Sasha. She ran 2 1/4 mile. Remember, we need to change 1/4 into something with an 8. So I know I need to multiply 4 by 2 to get 8. So I need to do the same to 1. So we have 2/8 or 2 2/8 for Sasha. So we're going to go over to 2 and count up 2. Put a dot for our girl Sasha. Let's keep going. Same thing with Tyler. Tyler has 2 2/4. And then our other 3 runners, Jenny, Anson, and Chandra, all have eighths in their mixed numbers or in their fractional units. What I want you to do is take time to put Tyler, Jenny, and Anson and Chandra's running points onto your dot plots where you think they belong. Pause the video, and when you come back, I will show you where I put those specific dots, and then we'll talk about some things we notice on our dot plot. As you can see, I added the final dots for Tyler, Jenny, Anson, and Chandra onto my dotted plot here. We had Jenny at 5/8 down here. Tyler and Chandra both added a point at about 2.5 or 2 4/8 or 2 2/4. And then our final one was our friend Anson, who got 2 2/8. If we were to look at all of this information on our graph here, we could make some different observations about these students. I can see that one of the students almost ran 3 whole miles. They were very close to doing that. And some students even ran the same distance. Those are the students that have multiple dots above the same number. We can also see that some of the distances we needed to convert. They weren't all given to us in eighths, so we might have needed to change some of our fractions from fourths and halves into eighths. But that's okay. We were still able to convert that and see the results on our final graph, our dot plot. And the basic information here is we can see that the students in Mrs. class pretty much all ran between 2 and 3 miles before they stopped running. Whew, that's a long distance. Now, you're going to continue to work on your problem set questions and learning more with dot plots. If you have any questions or specifics, ask your teacher for help. Good luck, mathematicians, and I'll see you guys soon.